We're going to work on some more intermediate examples on completing the square, and those examples will include odd values of b and leading coefficients of x squared. So just like converting circles to center radius form, the odd coefficients mean they're not divisible by 2. So this is very closely related because completing a square includes dividing by 2. So if you're working with an odd value, that means it won't be divisible, so we'll be working with fractions. So the first example we're going to work with is, let's say we have x times x minus 7 equals 5. And let's solve for x. Well, let's get this into standard form first. So we'll have to distribute the x. And let's subtract 5 from both sides. So we are in standard form, so we can begin completing the square. So let's take the b term, which is negative 7, and we'll divide that by 2. Now, the only problem here is that the previous examples that we've worked on had even coefficients of b, so this turned into be an integer result. In this case, that is my division of 2. So this is my factor, and this is what I will square. Negative 7 squared is positive 49, and 2 squared is 4. So this is a number I will add and subtract. So this is my factor, and this is my add and subtract. Again, your add and subtract comes directly after your x term. So we have x squared minus 7x plus 49 over 4 minus 49 over 4 minus 5 equals 0. So the first three terms are our factorable trinomial. Now this could take a while to think about the factors. Fortunately for us, as soon as you divide by 2, this is your factor. So we have x minus 7 over 2 times x minus 7 over 2 is x squared minus 7x plus 49 over 4. So again, fortunately, we don't have to think about it because this is my factor. And now let's combine like terms over here, but this term has a denominator of 4, but this term does not. So we have to multiply this term by 4 over 4. 5 over 1 times 4 over 4 is negative 20 over 4. And don't forget that this still equals 0. Let's combine like terms and stick it on the other side of the equal sign. X minus 7 over 2 squared equals 69 over 4. Let's take the square root of both sides. X minus 7 over 2 equals positive negative radical 69 over radical 4, 2. And now we'll add 7 over 2 to both sides. So x equals 7 over 2 plus or minus radical 69 over 2. The last thing we could do, since we have a common denominator, we could express this as one fraction, just because it looks a lot nicer. X equals 7 plus or minus radical 69 over 2. Alright, another example. And now let's throw a leading coefficient of x squared in there. Let's say we have 3x times x plus 3 equals 24. And let's solve for x. Let's distribute the 3x, giving us 3x squared plus 9x, and we'll subtract 24 within the same step. So now that we're in standard form, we can begin completing a square. However, this leading coefficient is giving us some trouble here. I cannot complete the square without a leading coefficient of 1. So I'm going to divide all terms by 3, including the 0. That's why we're able to do this. So we have x squared plus 3x minus 8 equals 0. Now we can begin completing the square, in which we take b, which is positive 3, and divide by 2. Square it. 9 over 4. This is our factor. And this is our add and subtract. So we're going to end up with x squared plus 3x plus 9 over 4 minus 9 over 4. Don't forget that negative 8 equals 0. And now we have a factorable trinomial. Good thing we don't have to think about it. This is the factor. X, well, it's positive, so plus 3 over 2 squared. Okay, now we'll combine like terms here. Minus 9 over 4. Since this has a denominator of 1 and this has a denominator of 4, I need to multiply this by 4 over 4. Don't forget it still equals 0. Let's combine like terms and throw it on the other side. And it's negative 9 minus 32 is negative 41 over 4. And now we'll take the square root of both sides. Positive, negative. Well, there was negative over here. I should have had a positive here. Sorry about that error there. Negative over here. I added it to both sides, so it's a positive radical 41 over radical 4, which is 2. And then lastly, we'll subtract 3 over 2 from both sides. Plus or minus radical 41 over 2. And let's just express this as one fraction so that it kind of looks like a quadratic formula solution. X equals negative 3 plus or minus radical 41 over 2. Last example. Let's say we had a coefficient of x squared and an odd value of b. Well, what do we do there? Well, first thing, we need a leading coefficient of 1, so let's divide everything by 2. So we get x squared plus 5 over 2x minus 2 equals 0. So now our b term is 5 over 2. We want to divide this by 2, which means multiply by half. There's our division of 2. There's our factor. When we square it, 25 over 16 is our add subtract. So this is our factor, because this division of 2 was simply to get a leading coefficient of 1. That was not our division of 2 to complete the square. Our division of 2 to complete the square yielded 5 over 4. And this is our add and subtract. So let's rewrite this. X squared plus 5 over 2x plus 25 over 16 minus 25 over 16 minus 2 equals 0. Here's our factorable trinomial. Now, this would take a really long time to sit there and think about factors. Fortunately for us, as soon as we divide by 2, that is our factor. So we have x plus 5 over 4 squared. And now let's combine like terms here, which means I would have had to multiply this by 16 over 16. So minus 25 over 16 minus 32 over 16 equals 0. X plus 5 over 4 squared equals, and let's combine like terms here, which is negative 57. So it's positive 57 over 16 on the other side. And now we'll take the square root of both sides. Positive negative, radical 57 over radical 16, which is 4. X equals negative 5 over 4, plus or minus radical 57 over 4, and then we'll just express it as one fraction. Because that's what it would look like if we had used the quadratic formula, which we would have ended up with the same result if we had used the quadratic formula.